starts with Zubair. Zubair, I want you to share your screen and proceed with sequence diagrams.
Okay, sure. You can see my screen?
Yeah. Yes, yes.
Yeah. So I've just made a small note about the sequence diagram. Okay, starting with the definition of what is a sequence diagram. Sequence diagram, it's like it's an interaction diagram that shows the interaction between two different objects in terms of messages. And this sequence diagram is also called as an event diagram, and it is the best way to visualize how the things flow in a runtime scenarios. That is a definition of a sequence diagram. Okay, and there are some basic notations that we should follow while creating a sequence diagram, and I have listed them here. The first and foremost basic notation of a sequence diagram is an object, which can also be called as a class. Now, this object means you can say, for example, in my in my library management system. Okay, this object can can represent a login page, for example. Okay, so this object can be a login page. So you can say it's a kind of a participant that is going to participate in your sequence diagram interactions. So login page is a part of my interaction. So it's a part of my object, the first page, that is the login page. Okay, and the next thing is the activation or execution occurrence. Okay, this is the big rectangle. This basically tells you the lifeline of an object. That is enough. For example, in a sequence diagram, one object can have a big lifeline, and some objects can have a small lifeline. That is where it starts and where it's going to end. So
this is what activeness of your interaction.
Activeness of an interaction of that particular object. So this is what it represents, this long rectangle. Okay, and then to interact with other objects, okay, we need to have messages, and the messages are shown here. They are like a different type of messages that we can interact with. They're like different type of messages where the objects interact with each other. Okay, some of them are shown here. Okay, like the first one is you can see a straight arrow, a long arrow. Okay, so this is called a synchronous message. That is the way commonly how an object interacts with other object. That is through this arrow. Okay, and above the arrow we can have a message showing that what it's going to interact with the other object. That is what action it's going to take to interact with the other objects. So this is what is one type of message. The other type of message that we have is a asynchronous message, which is represented by a half arrow line. And this asynchronous message, it basically is, it basically means that there is no response from the receiver. That is, for example, when there are two objects interacting, okay, when one object sends a message, the other object may send a response back. Okay, if there's no response back, then we can send that particular message from one object to other object with the asynchronous, with this.
Sorry, repeat that. First, repeat about asynchronous.
Yeah, asynchronous message means it is represented by this half arrow. What it means is, for example, let's say there are two objects, 1 and 2. Okay, when first object interacts with the second object, that is, let's say it's requesting something, the second object should give back to the sender. That is the receiver which is receiving the message. The second object should give it back to the sender. For example, if there is no response from the sender, if there's no response from the receiver back to the sender, then we use this arrow. That means we can continue with the flow. There's no response from the receiver to the sender, because sender sends a message. There may be a response from the receiver to the sender, but if you use this particular arrow, that means there's no need for a response. You can just continue with the flow of the sequence diagram. That is what this means.
Okay, good. So usually for synchronous, the sender waits for the message to be handled for next set of interactions. Whereas for asynchronous, the sender need not wait, or he's not sending any reply back.
Yeah. So we can use
this. He's not sending any message before he continues.
Correct. So we can just continue with the flow. Yeah, flow of events.
And you know what? Actually, there's other notation also for representing. Usually, this is with some applications. This is what we follow. Okay, messages. The synchronous message, what you have mentioned, the bold one, the arrow should, the head of the arrow must be bolded one.
Okay, okay, head of
Okay.
this. Okay.
If it
Yeah.
is simple arrow, then it is asynchronous. Okay, and you're fine with the reply. This is what we use as a reply notation.
Okay, 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 okay. Now this the other type of message is a dashed arrow. So that means whenever there's a response from the receiver to the sender, we write the response on this kind of it's that response is represented by this kind of arrow. That means it's a return message from the receiver to the sender.
Yeah, dotted arrow. Exactly.
Dash arrow. Okay, and this is another type of message that is whenever we are starting with a sequence diagram. That is when you are starting when a user is starting to interact with the sequence diagram. This is how it interacts with. Sorry, when the user is starting
Initiation.
to interact with the object. This is how he initiates with each object. That is the arrow should be marked to the top of the lifeline
Lifeline.
of
Yes.
that particular object. So this is how it starts. And if the user wants to destroy a particular object, then this is the symbol, the cross mark that is there. Okay, this is how it through this that means a particular object is destroyed at that particular point of time.
Yeah.
That is the destroy of an object. Then this is another symbol. That is if there's a message from some unknown object or unknown recipient. This is the symbol that we have for unknown recipient. And if you want to send a message to some unknown recipient, again this is from and this is to.
Okay, okay. This found and lost we don't use it frequently.
Yeah, even I've not seen in much of the sequence examples which I've found a lot, but I
And
just
rest
thought.
are majorly used. And yeah, go ahead.
Yeah, then the other type of message is a self message. That is, if the object is sending a message to itself, this is how it should represent.
Yeah, it's even called as reflexive communication.
Reflexive communication. Okay.
Okay, when an object talks with itself or communicates with itself. So.
Reflexive communication. Right. Okay. Okay. So this is about a self message. Then we have the last notation, which is called as a frame. So this frame can be of three types. It can be either optional, alternative, or a loop. If it's optional, that means it's an if message. That means it's a if there's a if condition for that particular frame. And if it's an
If or
alternate,
if not. I mean, you have an option to choose.
yeah, optional, if or if not, correct. And if it's alternate means it's if else. That is, it will be either if, then there should be a dashed line, and the next part will be else.
Exactly.
And if it's a loop, that means that particular part of the diagram should keep looping.
Yes, it happens multiple times.
Multiple times. So this
The process.
The process happened multiple times. So the opt, alt, and loop you keep mentioning here. So with the help of these three, these notations, you'll get to know whether it's an optional frame or an alt frame or a frame. So you should get it here. Actually, I could not write it because there was no.
Okay.
So these are the basic notations of a sequence diagram, which will help us to create a sequence diagram. Okay. And this is an example of a live example of my login page. Okay. Now we have a user. Okay. Now this is an example of just a login page. So in a login page, we have four objects. One is the login page itself, then the login validation, then what happens after the login validation, that is the home page. And if my login fails, that is the login failure page. So I have categorized them into four different objects.
Preferably mention this as after login page. I mean, I'm giving you the professional terms. We call it as after login page, and the initial page as welcome page.
Welcome page. Okay, perfect. Okay. Yeah. So now we can see the user, and you can see the lifeline. So it starts from here and ends till here. That means the user is active for the entire sequence diagram. I mean, for the entire interaction of the object.
Right from the initiation till he gets the confirmation.
The confirmation, correct. Now, the first thing what the user does is he obviously visits the page. So when he visits the page, so this lifeline you see it's small. So that's the only lifeline of this login page. He visits, nothing else he doesn't do anything. Next thing what he do after he visits the page, he enters his username and password. Okay, now you can see the lifeline of the username password is still end, and in between all these processes are happening. Okay, so the moment he enters
Why is the lifeline little? I mean, I'm talking about the visit interaction. Why you're ending there?
I thought like visit is only like viewing the page, and
Once you get the reply, then only it ends. The activeness ends, or else it won't end.
it okay. Okay.
Is it your own example, or you came up with? I mean, is it
No,
from
no,
Google?
it's from Google. It's not my example.
Okay, okay, fine. Usually, see, if at all, if you're for any interaction, you need to have a complete reply for that, right? See,
Okay.
like for example, if you're visiting the page,
Yeah.
login page, okay,
Yeah.
user accesses the page and system prompts with something. System prompts with welcome page. That should be your reply.
Oh, okay. Okay. Okay.
Got
So,
it?
so
Then you can end the process, or else it's like a continuous process, right?
okay. Okay. That is how
Okay,
it ends,
let's
right?
imagine that we are ending there. I mean, once we are visiting a login page or accessing a login page and we are not able to access it, then
Yeah.
it should not be a synchronous, right? Then it should be asynchronous.
Correct. Yeah.
Okay, there's something wrong with the first interaction.
Mm-hmm.
Maybe I need to get the scenario then.
Okay.
Okay, carry on.
Okay. So ideally, how does the this activation, this lifeline ends? Basically, for example, if I'm interacting with the first login page and I create a lifeline, then how does that particular lifeline end? Only if it gets a response?
Yes, response means either it is positive or negative. You're logging in,
And
that means you should get a reply from your object that you are logged in and it is taking you to after login page. Or
okay.
something is displayed to you on the screen. Once you get a proper reply, then your activeness ends.
Okay, okay. That is, for example, if there's no reply, then I can use this as a asynchronous message and just end it here.
Yes.
Oh,
Yes, that obvious, right? Like there won't be any further communication.
exactly. Yeah. Okay, okay.
Yeah, the bold one means it's a synchronous message.
Synchronous message. Okay. Yeah. Hmm.
Maybe why don't you go with different example?
Okay, I'll go with another example.
Shola, any questions? Maybe you can chat if you're not able to, I mean, if your audio is not working. But I'm not able to hear anything from Shola, Arjun. Oh, he's in mute. Why so? Okay, maybe some, I mean, you want to avoid some disturbances, but still, we can chat, right?
Me?
Shola.
Hello? Can you hear me?
Hi. Yes, yes, I
Can you
can
hear
hear
me?
you. Any doubts?
No, I just want to know that you can hear me now.
Yes, yes, it's perfect for me.
Okay, let's go on then.
Okay, okay.
Uh, this example will take.
Perfect, yeah, you can go ahead.
Okay, so in this you see we have 1, 2, 3, 4, 5, 6. Okay, can we mark objects like this in a circle manner?
Uh, uh, it can be done, but usually you need to aware again. See the difference between these objects. The arrow is also included. It's like reflexive, or we are
Yeah,
not sure of the communication part. It's better to use rectangles.
rectangles. Okay, okay. So rectangles only are the best practices to use.
Mhm.
Fine. So now in this we have 1, 2, 3, 4, 6 of them, 6 classes, which we have divided this ATM model. And the first thing what the user does is he interacts with the front end, the GUI, the graphical user interface of the screen. So that is the beginning of the session. So once he interacts, then second step, what he does is there's a login page, okay, that he normally gets on an ATM machine. So there he,
It is asynchronous because we are not bothering what happens next.
yeah, what happens? Yeah, this is asynchronous, and then this is a login ATM, okay, and again from here he says we have to, there's a data entry, that is he has to key
Yeah,
in
this
some.
is synchronous because once you log in, you need to enter your data. I mean, you need to enter your credentials.
Credentials, okay.
The next, I mean, it's followed by login, right?
Followed by login, yeah. And
this is followed by entering, I mean, clicking on login button.
Login, this is followed by clicking on login button. Okay, okay. Okay. And then there's a response back. Okay, the response back, that is you have to select the card, that is which card you want to select. Okay, then again the user interacts with login saying that this is the card I want to select. Okay, and then again it goes and logins with that particular card. And then it starts. Okay, I think this is not complete.
Starts a new session if you're done with. I mean, once you're log out, then only it should start new session.
Yeah.
Usually these sequence diagrams are helpful for your developers. Okay, based on the interaction details, they'll come up with the code, like how your user should behave with the objects.
Okay. Okay. Can I build my
object-to-object communication?
Okay. Can I build my own?
Yes, that's perfectly all right. Yeah.
I'll explain to you my own what I have understood and all.
Okay.
Just have taken this one.
Yes, I am.
Hello?
Yes, I'm here.
Yeah. Yeah. Actually, you want me to draw the diagram now?
No. Take your time. Maybe I'm expecting you to give me a scenario at least.
Yeah.
You want to do it for login process itself?
Yeah. I'll do for login page for my library management.
Okay. That will be fine. That will be fine. Perfect.
Yeah, I'll do it.
And Shola, what about you? Collaboration diagrams?
Ashwini,
You can stop sharing.
hello, Ashwini. Sorry to interrupt. Before we move on with Shola, can you give a feedback on my explanation skills?
Yeah, it's perfect. You have included all the things. So wherever required, I have given inputs, right? Like about synchronous, asynchronous, and the notations part. Okay.
Okay. And my explanation.
And for delete one, you have something called self-deletion.
Self-deletion. Okay.
Yeah, there's something called self-deletion. When the object destroys itself, then it is self-deletion.
Okay.
Other than that, you have included everything. Yes, it's perfect.
Okay.
Now you can start working on an example.
Perfect.
Okay. And please share this document with me.
This one, huh? Sure, no problem.
Yes. Okay. Maybe I'll update this and then send it to you.
Yeah, perfect. Yeah, and also I'll share my my project with you, and I would share also my use case document which I'm going to prepare for my this thing.
Okay.
Actually, tomorrow I've got a weekend, so probably tomorrow.
And I haven't received any document from you, the requirement document.
No. I'll send it to you because tomorrow was a weekend, not tomorrow, so I can just finish off the task.
Okay.
I thought like I'll send it to you today evening, tomorrow morning. Probably.
Perfect.
Yeah.
Okay, good. Yes, Shola. Okay, I guess you need a control, right?
No.
You can stop.
Okay, give me the control. Let me talk. First is that I checked through all the even glyph and Visio. I couldn't get UML for collaboration. Are you here with me? I said can't find. Yeah, I said I can't find UML for collaboration, and that make it difficult for me to even see all the notation for collaboration and how to come up with a drawing. Because I tried to now use a sequence UML, but it wasn't giving me what I expected. So if you share my screen with you.
I can't see your screen now.
Because
Arjun, please give the control to.
But are you hearing me? Are you hearing me?
Yes, I'm able to hear you. Yes.
Yeah. So what I did I just went to Google Image and see how a collaboration is, right? And based on that, I just come up with a little drawing. But I have to how to get UML for collaboration, because I can only see UML for classes. I know UML for activities, UML for sequence, UML. So I don't know how to get that. But this is what I just.
Fine, yeah. Not even with Glyphy?
Say again?
Have you tried with Glyphy? It should work. I mean, under UML diagrams, you have collaborations under.
Yes. On Glyphy, I didn't get it. This is it. I didn't get it. Yes, there is no collaboration UML. Is it? Because I tried it yesterday. All the UML that I got.
Maybe because, you know, okay, fine. First you carry on with your explanation, then I'll tell you.
Say again?
You can carry on with your explanation on this, whatever you did, then we'll carry on, okay?
Okay. So on this, based on my, just looking at some images on Google, I just try to figure out what collaboration is all about. And my understanding is that collaboration is like there is a central process. It's similar to bringing use cases into action, trying to, you know, specify what the key functionalities are. So, for instance, in this case, this is adjuster, which is the person that do the, you know, I just need to come up with something. So this guy received the claim. So when he received the claim, he goes to reviewing the claim. That's a process, and evaluating the loss, and as well, I need to scroll it down, and as well processing the payment.
Yeah, scroll a different whole. I mean, you're scrolling a different one.
Okay, I'm scrolling a different one. Okay, sorry. I'm coming. Okay, here, yeah. So so this same guy perform major functions. When he received the claim, he has to review the claim, then evaluate the loss, then process the payment, and the payment will come to whether being claim payment being made or the claim payment is denied.
Okay.
So that's all that I have.
Okay. What exactly you're trying to communicate using collaboration diagrams?
Yeah.
No, I'm asking you, what is that you're trying to communicate using collaboration diagrams?
What I'm trying to communicate is that showing what this actor is doing in the process of the claim payment. That's all.
No, not with respect to this example. In general, why we use collaboration diagrams?
Okay. Maybe I don't have an answer to it, but my understanding is that we want to actually show the key functionality of a process. That's why we use collaboration diagram.
Okay. Okay. So again, your task is to find out the difference between sequence and collaboration. Okay, I'll give a hint. Maybe you can stop sharing at your end if you're done with explanation.
Okay.
Thank you.
I'm not in the control.
Yeah, thank you. Actually, once you're, as I said, under interaction diagrams, we have sequence and collaborations together, right? So once you're done with the sequence diagram, for the same diagram, you'll be listing out the flow. in a collaboration diagram. So collaboration diagrams are used to give the exact flow, what happens between your actors and objects. See, this is a simple example related to a customer filling a credit form and getting a confirmation code. So look at this, a customer, these are the objects, credit form, processor, and confirmation form. So whenever customer submits credit info, he fills the credit form, then processor will be checking the credit details. So based on that, he will reserve a seat at his end. And based on that, he'll generate a confirmation code. Again, this generation is happening at the processor end itself. So once the confirmation code is generated, okay. So this is the step-by-step process. First is submit credit info, second is check credit, third is reserve seat, fourth is generate confirmation code, and fifth one is display confirmation. This is what we give in a collaboration time. That's it. That is the only difference. So a thin line difference, I want you to define exactly what it is. That assignment, Shola. See?
You see?
Yes. No.
Ashwin, Ashwini. The question here is that even if I want to define it, right, and come up with pictures, I really need to see a template that I have to draw on. With all the materials I have now, I can't even get collaboration UML. That's what I'm saying. So you need to even tell me all together before I need to do anything.
Okay, so fine. I'll explain you, not a problem. So what are you expecting from me other than this? Like, I hope now you got the difference why we use collaboration diagrams.
Not so yet clear to me anyways.
Okay.
Between
fine. Are you through with sequence? No, are you through with sequence?
You mean me?
Yes, Shola.
Okay, I didn't work on sequence at all. I didn't even
just
check
now,
it.
So they explained it.
Yeah, but mentioned to you, I didn't even hear all the explanation. I just be able to get into hearing you. That's why I was sending chat that I cannot hear everything that you guys are saying. So I just joined just when it's about to. That's when I was able to hear everything you guys were talking about.
Fine. So then what I want you to do is, maybe you'll be having the recording, right? Like once we are done with the session, you'll be having the recording, right? Go through with that recording. Okay. Then don't work on collaboration now, okay? Just work on sequence, whatever we have discussed, and don't even go to Google also. Just concentrate on what Zubair has explained today. Just this 30-minute session, that's it. So based on that, then I'll explain you what collaboration diagrams are and how different they are from interaction sequence diagrams. Fine?
Okay. Okay.
Will that work?
Yeah, that's okay. That's fine.
Okay. Now, let's go with class diagrams, okay?
Ashwini, I have just one out in the sequence diagram.
Yeah.
In the diagram which you showed before, the sequence diagram. Just go on top. Yeah. This is so in this the fifth part, the display confirmation. When we are displaying the confirmation, we are going through this confirmation form. Okay, is it a confirmation form? It's not a message, right? It's a confirmation form. It's a different object altogether. A form is displayed.
Oh, yeah. It's a different object altogether, and actually there should be reply also. I mean, this shown to your customer. One reply is missing. Then the interaction ends.
Exactly. Yeah. Perfect.
Got it?
Got it. Yeah. Perfect. Yeah.
And even you can concentrate on the length vertical bars.
Yeah. Like Ashwini, how do you know that like this for the credit form, the lifeline is shorter than the customer?
Okay. See, as soon as we submit credit info, then only the interaction starts with credit form, right?
Yeah, correct.
Then we need to start it here, little lower than this, okay?
Yeah.
Then, based on this, I mean, after we have received this interaction, then credit processor will be looking into the details, whatever the customer has filled in. Then he'll reserve a seat and generate a confirmation. See, this is perfect. Starting at a different end, a little lower than this end.
Lower than this end. Okay. Okay. Now, in this in the credit form, we see the lifeline of the credit form. This lifeline is shorter than the customer, the lifeline.
Yeah.
The,
Yes, because once credit processors receive it, he's not going to look into that again, right?
Okay. Okay. Okay.
Once he confirms, he's not going to look into that because he's already read upon what to do with that form.
Okay. The form. Okay.
Only till that is active.
Okay.
Got it?
Yeah. Okay. So that is the credit form includes the credit. So this lifeline should also include the credit processor lifeline as well.
Yes. Yes.
Okay.
Usually, the simple way to come up with a sequence diagram is you need to imagine what is between you and the packet, and how far your activity or how far your interaction is active in between you. I mean, both you as a user and the backend.
Perfect. Okay. Okay. Got it.
Okay.
Perfect. Yeah.
So, Shola, I hope you're through with your task. You to go through this recording again. Okay.
Okay.
If not, also fine. Like if you're not able to get anything, I'll explain you again everything. I mean, even sequence and collaboration.
Okay.
So today,
Thank you.
now we'll go with class. So
Okay.
these are the 4 major diagrams which we'll be using as a business analyst. Okay, these are more than enough for you. And to be very specifically, you'll be using activity and use cases, nothing more than that.
Exactly. Correct.
Activity, use cases, and on top of these 2 things, wireframes. Wireframes are important one under UML. Okay.
Okay.
Yeah. Ashwini.
Yeah.
Yeah. Sorry. What is mainframe?
Sorry.
Mainframe. What is mainframe?
No, I'm not talking about mainframe. I'm talking about wireframe.
I know, but I'm just asking what mainframe? Yes.
We use IBM mainframe for coding. Okay, it's a platform actually.
Oh, it's a platform for coding.
Yes.
Oh, wow.
You might have heard people mentioning that they were IBM mainframes. I mean, they work on IBM mainframes.
Yes, I've had people talking about it, so I said, what was that?
Okay. Don't worry, it's not related to us. Just a second, give me a minute.
Okay.
I hope you are able to see my screen.
Yeah.
Okay.
Yeah.
So usually we use class diagrams to give the relations between multiple classes, or it's even called as, I mean, it's even a type of entity relationship diagram. Okay? All the classes are entities for you. So how we represent is, okay, but before representation, just read this definition. As I said, it's a simple way of explaining the interaction between your entities. Okay? Entity relationship. So we use class diagrams like this. Like the notation is, it has got 3 different columns. Okay. In the first column, you'll be writing about the class name. Second column, the class attributes. And third column, we list all the operations what we are performing on that particular class. Okay. So let's, for example, loan account is a class name for us, and all the related attributes like what is the type of loan and what is the account name and date released or loan amount, all these are attributes for you. For example, let's say if I take customer as a class, what do the attributes are for a customer class? customer details. Let's say, for example, if I pick customer as the class, okay, a customer a customer doing a shopping, okay, taking some order and paying for that. For that particular customer class, what do you think the attributes are?
Name of the customer, mobile number of the customer, address of the customer.
Yes, his details are his attributes, and the operations, maybe he'll proceed with shopping. Okay?
Shopping, yeah.
With respect to this loan account, like he can renew, extend, or update, or delete. All these are operations what we perform on this class. Okay, this is the depiction. Okay. Now we have 6 different relations to relate a class. So these are categorized as association, reflexive, multiplicity, aggregation. It's a part of it. I mean, aggregation is part of association. I'll tell you. Composition, then inheritance or generalization, then realization. Okay. Look at this. A simple relation, or to mention that there's a relation between 2 classes, we use association. Okay. So it is depicted like this. Got it?
Yeah, perfect. Yeah.
So this is 2 classes, passenger and airplane.
Exactly. These 2 classes, these 2 are the classes, and passengers are associated with airplane. Okay. There's a relation between passengers and airplane. Got it? Now, reflexive association. It's more like reflexive communication when a class communicates with itself. Okay.
Okay.
Fine. Now, airline staff, look at the relation. I'll explain you about 0 star and like these relations later, okay?
Correct.
But before that, reflexive communication, as I said, it has got, I mean, it's communicating with itself. Look at this example. A staff working in an airport, maybe a pilot, aviation engineer. All these are the same. I mean, these are airline staff itself, right?
Yeah.
Categorized as airline staff, it may be anyone. A pilot, maybe a airline staff, activation engineer, or ticket dispatcher. Got it?
Correct. Yeah.
And multiplicity. Can you guess what is a multiplicity by its name?
Multiplicity is like, let's say one class is can be related to how many other classes?
Exactly. Yes. Multiplicity is depicting, or how many times your class will occur, or how many relations you have with the main class.
Correct.
Okay. So
yes.
For a given airplane, you'll be having multiple passengers, right? Or what you call that, a fleet. Fleet is nothing but where the airlines are parked. Okay. It is having it will have multiple airplanes parked, right? So it's a multiplicity for us, and one airplane will be having multiple passengers.
Correct.
Got it?
Got it.
Then, yeah, this is what I'm talking about. Aggregation. Aggregation is nothing but it's a part of it. A class is a part of it. Okay. So books are part of library. Okay. Or like one more example is sentences are part of paragraph. Okay. Words are part of sentence. Got it? So words are aggregated with sentence. Sentences are aggregated with paragraph, and paragraph is aggregated with book. Got it?
Yeah.
Got it.
Yeah.
Good. Now, there's a simple difference again between aggregation and composition. So composition is nothing but which is entirely made up of, concentrate on this, entirely made up of your class, subclass. Without that, it won't exist. Like for example, without legs or without hands, your this person class, that it won't exist.
Correct.
So person is composed of leg and hand, legs and hands in fact. Okay.
Correct.
Just remember these terms. Aggregation is part of it. Composition is entirely made of. Now, one more is inheritance generalization. Usually, inheritance is nothing but you inherit the properties of your parent class, parent subclass relation. Sorry, parent classes. So your child will inherit some properties from parent. So same is applicable here. So usually bank account, there might be multiple accounts, right? So fixed account is one such account which will inherit some properties from bank account. Not exactly the same, only some properties are inherited, right?
Correct.
There might be savings account, there might be credit account. All these are child classes. For these child classes, the parent class is bank account, okay, which will inherit some properties. Like for example, you might have inherited some properties from your dad or mother. They are your parent classes. You are a child class. Okay.
Yeah.
One more confusing thing might be confusing for you, but it is simple. Realization means the proper interface between the classes, two different classes, which will, without which you won't be able to proceed with the implementation of the class.
Correct.
Without the printer set, you cannot proceed using your printer, right?
Yeah.
I hope you got this example. Fine.
Yeah.
Usually we'll be using a dotted arrow or like hashed arrow for representing organization. Okay, so these are 6 along with association. You have seven relations to relate a class diagram. Now, actually, one second. So these are the relations I'm talking about. In between two different classes, along with inheritance, aggregation, composition, you use these numbers, okay, depending on the sets. So it may be 0 to 1 relation, or simply 1 relation, or 0 star. 0 star is including 0, 1, 2, 3, and so on. 1 starts from 1, which it is not including 0. These are the 4 relations you use to relate your classes. Sorry.
Correct.
Fine. Now, this is an example. So before I go with this example, I hope you're through with what apps association or generalization, multiplicity, and all.
Yeah.
Or the composition aggregation too. Now, now your task is take your time, go through with this diagram first, okay, and let me know your understanding. Then I'll explain you my part.
Okay. Perfect. Yeah.
Ashwini?
Yes, Shola.
Okay, I'm wondering that are we still on?
Sorry?
No, I'm wondering are we still on?
You're wondering about?
If we are still in this session, because everything went silent.
No, actually I wanted you to go with it, right? Like waiting for your response. Are you through with this?
Okay.
Yeah,
oh, even from my side, I hardly see all the letters. I can't see what are in the boxes.
Okay, let me see.
Yeah.
What about you, Zubair?
No, for me it's clear.
Okay.
Okay, a bit better. Mm-hmm.
Done?
Yeah.
Okay. Maybe Shola, I want you to explain first.
Yeah. The first class is customer, and those are the object, the details, the address. Yeah, and after that, the second one is order, which is second class, and that's from customer to order. There is association between them, and that is the relationship for the association is that the customer and the order they have it's association. Yeah. So the association is that from being a customer to make you have to be a customer to go into the order.
Okay, but okay. Actually, a customer can go to a store and he may or may not purchase. Okay? Maybe he'll go to a store and he'll do some window shopping and come back without any purchases.
Yeah.
That's the reason it is 0 star. Okay. If it is doing or if it is mandatory to shop, then it will be 1 star. Okay. So this is all about customer shopping and proceeding with order, and for that order he'll proceed with payments, and there may be sorry, for payment we have three different options. So that's the reason it is generalization.
Credit card, check and those are generalization or inheritance to payment. That is, before you could make payment, you must have your payment will come from any of these. So these are like parent to payment. So you must have credit or have cash or check. Then you can get deduct payment from that one, generate payment from either of them. So that's where relationship is generalization or inheritance. Then if we come to other details, that is, if we come to other details, now since one, it's a compulsory, 1 point, then from the other details there is multiplicity. Yeah, the other details to order, it's compulsory because once you have made the order, you have the details of the order you have, maybe all the types of items and everything. It is a must for you to have details. Then the multiplicity shows that there are still other items that were dependent, or they have more than one activities with the other details. They have more than one relationship with the other details.
Yeah,
And,
the condition, the condition over here is like, okay, before we go with this, look at this navigability. That means it can either be this direction or the other way. Okay. Then all the items together form your order detail, and multiple order details together form your final order. Okay. So now, as I said, your item will be minimum 1. Okay. For a given order detail, you need to have minimum 1 item or no item at all. So not no item, minimum 1 item, and based on your order details, it may or may not be again. Altogether, all your order details together form your final order. Let's say, for example, if your customer is making purchases in kids section, that's one order detail, and groceries as one section, that is one order detail, and footwear as one order detail. So all together, these 3 order details will form your final order. Okay, that's the reason it is aggregation, 1 star to 1.
Yeah. Then, Ashwini, from this diagram, if we look at customer class, the step from customer class, it goes to order. Now, is it also starting from item to go to order details, then go to the main order?
Sorry, repeat that. From customer to order, what is that?
No, I'm saying that this, now, does it have to, the way we are going to draw it, do we have to have in mind where the process is starting from? Now,
exactly.
If the process, if class customer as a class, that is where the process starts from. So it goes to the order.
Yes.
Yeah, good. Then after the order, it comes to payment, which is a good move. Then the payment has options where the payment can come from. That's a good one.
Yes.
Now, I'm now relating it to the same over here, the last column, the last class, the item class, the last one. That one. Is this one as a thread? Is it the starting point? Because the way the arrow is.
Oh, like, no. Actually, it's not like it's starting point. Even you can include items and order details. Unless your customer pick items, you can't decide upon items, right?
Yes.
So these two are like, based on these two, your order detail is developed. It's like a backend for you.
Okay.
From where exactly you're getting your order detail.
Okay. So,
for example, let's say.
That is an item like backend transactions.
Yes. Wait. See, let's say, Shola, if I want you to book a movie ticket using a mobile application.
Okay.
So what you do, you start searching for movies, right? So movies will be one class for you, and theaters will be one class for you. I mean, in which theaters it is having. And under that, your subclass will be the timings, the number of shows. Then you start relating it with the customer class, right?
Yeah.
So this is how we come up with the class diagram. First, you need to have an idea on the scenario, then list out the classes based on the activity or based on the functionality, and start relating with them.
Okay.
Got it?
Yeah.
Zubair, any questions?
No questions.
Okay, fine. So, okay, okay, fine. I want you to work on a class diagram. Zubair, you'll be working on a mobile application to book a movie ticket. Okay, for this one, I want you to come up with the class diagram. And Shola, you'll be working on booking a pizza online.
Doing what?
Pizza.
Pizza.
Exactly, yeah.
Booking pizza online.
Yeah, okay. So, This is for you, Shola, and it's a way you'll be working on that movie ticket. Okay.
Movie ticket.
Oh, booking pizza online. Okay.
Start with as per your understandings. If not, I'll also help you on how to come up with the assignment.
Okay.
Perfect. Yeah.
Okay. So, any more questions for today?
No. Actually, I'll just forward my use case document and my requirements, high-level requirements to you, as well as the SRS. SRS probably I'll forward it today. I'll forward you the high-level requirements and all.
Okay, okay. And also, like, maybe we are done with the UML diagrams. We need to start with testing. Okay, maybe with within 1 or 2. I mean, 2 or 3 sessions will finish everything.
Okay. Okay. Yeah.
Okay then. Bye for now. Take care.
Yeah. Take care.
Yeah.
Yeah.
Bye, Arjun.